This is Lisa Huff, Senior Principal Analyst, Optical Components for Omdia. I'm going to talk about data center optics, and specifically 400G and above rollout and the promise of co-package optics. First, I'll talk about ICP data center spending. Then I'll go into some of the network, coherent optics in DCI and service provider networks, and then data center datacom optics. So those optics used inside the data center. These two charts show the top line trends for ICP data centers. The cloud continues its rise. Now we see 26.2% of total communications provider industry CapEx is ICP data centers. And that's up from 11.8% in second quarter of 2014. The growth is coming mainly from Amazon, Facebook, Google, and Microsoft, and is being driven by outsourcing from enterprises into the cloud, as well as work from home workers in 2020, especially for CSPs, so all communication service providers. And what this does is drive more server deployments and higher data rate connections between those servers and between data centers. The bottom chart here shows the astronomical growth of Microsoft and AWS alone. In 2015, their revenue was less than $10 billion. In the first half of 2021, it was $70 billion. Now let's look at the networks behind these massive data centers. This chart shows the deployed bandwidth and how it is growing exponentially. The deployed bandwidth of coherent ports has grown approximately 30% between 2020, or is expected to grow between 2020 and 2025. In the Chinese market, we see 200G CFP2 pluggables. For ICP data centers, we see a high growth rate of 400G ZR. And for both ICP data centers and communication service providers, we see 600G and 800G growing over the next 6 years. This is showing the architecture change for data center interconnect. So today we still have a lot of traditional DWDM coherent transport between data centers. So we have an edge router, a DWDM optical transport piece of equipment. There's a short connection between those, and then the long connection between the DWDM equipment. That is starting to change, especially for ICP data centers. They are adopting this 400G ZR that will be used directly in switch routers. So if you look at the difference in architecture, it eliminates this DWDM box on both ends. Now, actually, Microsoft started this at 100G when they adopted the color Z from Inphi. So let's talk more about 400G. So we talked about 400G. Amazon and Microsoft will both be deploying this 400G ZR in switch routers starting this year. It has been dominated by embedded products, so those products that are not pluggables, that are used directly in optical networking equipment. But we see that converting to 600G and 800G embedded products, or being used when it's used in the metro, a new pluggable CFP2 module an Open ROADM ZR Plus, and Open ROADM. Open ZR Plus and Open ROADM, excuse me. This shows the forecast of 400G. We have point-to-point, which is the switch routers, metro, and long haul. In 2020, it was less than 100,000 units. In 2025, we expect it to be close to 500,000 units. For 600G, that was released in 2019. There's been strong adoption. There were 50,000 units done in 2020. It's currently only available in line cars and compact modular. We do not expect it to become available in a pluggable version. It will be used mostly in metro and long haul. There may be some DCI connections and maybe some subsea connections, but mostly metro and long haul. And the DSPs used in the 200G come from Nokia, Acacia, or NEL. For 800G, Ciena is the leader in this market. They've got over 80 customers, and the applications go from DCI up through subsea. In 2020, we saw the adoption very slow adoption. We expect it to pick up in 2021 and 2022. Other equipment manufacturers that have 800G products ready to go are Infinera and Nokia. Huawei demonstrated 800G last year, but has not marketed it recently because of supply chain issues with getting the DSP. We are expecting an 800G pluggable by 2024, 2025. Beyond 800G, the industry seems to be bifurcating. It looks like some of the equipment manufacturers may skip CMOS generations, so some will do 5 nanometers, some won't, some will do 3, some will do 2.1. That just remains to be seen, and it depends on the equipment manufacturer. We see the high performance or the embedded solutions for longer distances versus space and power optimized for shorter distances like the ZR. We also see a bifurcation following different models. So for ICP data centers. So some ICP data centers are going 100 to 400, some are going 100 to 200, some are going 200 to 800, and they all seem to be on a different path. For shorter distances, coherent may become feasible for about a 10 kilometer and maybe at 800G, depending on pricing, power consumption, and how it plays against the LR variant for the data center. Now let's look at short reach data center optics. This chart just shows the generation upgrades for ICP Ethernet switching architecture going from 2016 to 2029 from the leaf, the spine, and the top of rack. So the generations of Broadcom's Tomahawk, Innovium's Terralinks, Intel's Tofino, and starting in 2019, Cisco's Silicon One. The network architecture at 400G doesn't look like it's going to change. It may change a little bit in 800 or 1600 if co-packaged optics starts becoming a reality. At this point, Omdia doesn't think that's going to happen at 800G. We believe that co-packaged optics will impact the architecture later in our forecasting period, so 2024 at the earliest. So let's talk about Microsoft's change in architecture and the promise of co-packaged optics. So this right here shows Microsoft data centers today at 100G. So it connects its servers to top-of-rack switches with a 50G direct attached copper cable, which is less than 2 meters. Then from top of rack to tier 1 or leaf is 100G AOCs for less than 30 meters. Then tier 1 to tier 2 or leaf to spine, 100G PSM4 modules. And then outside or between data centers, the 100G DWDM PAM4 or the Inphi Color Z at this point. Now that is changing to 400G. So from server, 100G direct attached copper cable from server to top of rack switch. From top of rack to tier 1, 400G AOCs. From tier 1 to tier 2, 400G DR4, which the DR4 is 500 meters, but it could go up to 1 kilometer for Microsoft. So DR4, FR4. And then outside, between data centers, 400G DWDM or 400G ZR. Now, let's take a look at this rack to tier 1. This is where co-packaged optics will start to play. So, like I said before, this is a direct attached copper from server to top of rack and AOC from top of rack to tier 1. But if co-packaged optics gets deployed, Microsoft sees this changing to a top of rack bypass multi-homed NIC. So in other words, no top of rack switch. There would be a co-packaged optics on each server, which would connect to a patch panel, then the patch panel to a tier 1 switch, eliminating the top of rack switch. Now, this is Microsoft's implementation. They don't think they'll get there until about 2023 or beyond. Not all ICP data centers will be doing this. This is just another example of the use of a co-packaged optics. This is NVIDIA's solution for GPU to GPU connections, so graphics chips, from one graphics chip in one server to another. Let's look at the market for these devices. So when we look at the Datacom pluggable transceiver market by vertical market, you can see that ICP data centers dominated. In 2020, 65% of the Datacom pluggable transceivers were sold into ICP data centers, 21% to enterprise data centers, and 14% to local area networking. By 2026, we expect it to be 80% ICP data centers, 7% enterprise data centers, and 13% local area networking. And when we zero in on data centers, we see that ICP data centers 76%, enterprise data center 24% in 2020. By 2026, ICP data centers are going to be 92% of the market. Clearly, ICP data centers dominate the data center market. When we look at the high-speed Datacom pluggable transceivers by data rate, which is this chart shown here, it reached $2.9 billion in 2020 and is expected to exceed about $3 billion in 2021. By 2026, it's supposed to be $8.5 billion. It's a 6-year CAGR of 43% overall. The largest growing data rate is 400G. 800G will start to become a factor in 2026. And a portion of this forecast may turn into co-packaged optics. Omdia at this point is not forecasting co-packaged optics because it is too early in the market. The products have not been developed yet, and the ecosystem really doesn't exist to support a product. The market for Datacom 400G pluggable transceivers is shown here. This shows by variant, and you can clearly see that the expected growth rate is supposed to be 63% over the next 6 years. So from 300 million in 2020 to over 6 billion in, or almost 6 billion in 2026. The variant that you can see here that's going to be the most of the revenue is going to be 400G DR4, which is a 500 meter variant, followed by FR4, which is the 2 kilometer variant. If you look at 400 and 800 together, 800 will start to be deployed in 2022, but really it's with a slow ramp until 2026. And what we expect to become co-packaged optics is just a portion of that 800 gig market to start. Thank you for your time. I appreciate your attention.